In this video, we're going to discuss normalization. Normalization is a concept in relational databases that allows us to store data in a way that reduces redundancy and decreases the chance that there are errors and anomalies within the data. Essentially what we do is we take a very large table of data and we separate it out into little tables that are related together to achieve that goal. So we use normalization to reduce redundancy. We also allow it to be more extensible. And that means that we can add additional tables later and still have these relationships. And we use this primarily when we are designing database systems. On the other hand, we want to take tables from various databases and combine them all together through the use of queries to create one large dataset in a process that we call denormalization. We use denormalization when we want to summarize data, and especially when we're going to be performing data analysis. In data analysis, we're looking for patterns in a large set of data, and so efficiencies are not necessarily our primary concern. We also sometimes call this an extract of the data. So with normalization and denormalization, we're going back and forth. Denormalized data is for analysis, normalized data is for efficient storage. In the early days of computers, when storage space was very expensive, we had to be as efficient as possible. In order to accomplish normalization, we have something called normal form. And normal form reaches different levels of compatibility. So for example, we have our first normal form, or 1NF. First normal form means that we have to have fields that only have single values. So for example, if I had a field that was a name, and I put a first name and a last name, I would want to separate that out into two separate columns, two separate attributes, so that I could store that more efficiently. Second normal form is now when we're going to find the attributes and only include attributes that describe the primary key. So when we're separating these out, if I had something like sales, and in my sales table I had a sales order number, and I had a date, and I had a customer, and an address. The customer and address all describe a customer that I could represent with a primary key. So I'd want that separated out into a customer table and not included directly in my sales table. So with second normal form, we're separating out tables and attributes so that they only describe the objects that we're looking at. In third normal form, we look at the attributes once again, and we make sure that the attributes have no transitive dependencies. Meaning, looking back at the sales example, if I had sales and a sales order date, and I had a customer's birth date, I would want to make sure that I move that from the sales table over to the customer's table where it describes that thing. Essentially, with third normal form, we want every table to only contain a primary key and attributes that only describe that primary key and not other data from other tables. There's some examples of this on the notes that I've posted for class. So why do we do this? Well, there are three specific anomalies that we're trying to avoid by putting our databases in third normal form. Let's say that I have this sales table. And in the sales table, I have some attributes. So I have an order number, I have a date, I have an amount, I have a customer, and I have a customer address. If I put all this together in one single table, I'm going to run into some anomalies, meaning errors that could potentially cause problems with my data quality. The first anomaly is what we call a create anomaly. In the create anomaly, it means that all data must be present in order for me to record a value. So say I want to collect customer information, like here I have a customer Teeter who lives on Broad Street. In order for me to get that customer data, I would also need a sales order, a date, and an amount for that. Now, businesses rely on leads from customers and collecting customer information before sales are even made. So this is an inefficient way to collect data. I wouldn't be able to have sales information for customers without having the entire sales record. The second anomaly that we see is what we call the update anomaly. The update anomaly results in inconsistent data. So what does that mean? Well, let's say I have an order that I record. I have order number 1001 on 9/28, and the amount is $400. I have a subsequent order that is now 1002. This is on 9/29 for an amount of $100, and I put in my customer, but this time when I put in the customer information, the customer's address has changed. So instead of Teeter being on Broad, Teeter is now on Central. So what happens is when I'm collecting this data for this customer, I now have two customers named Teeter, and they both reside in different addresses. So which one's correct? Well, we could make some assumptions saying maybe the latest one is the correct one. But if I'm trying to send mailing information out to customers, I don't want to send mailers to wrong addresses. That would be expensive. So now I have inconsistent data. I'm not sure which one is the correct one. And then the third problem is we have something called a delete anomaly. The delete anomaly makes it possible that we can lose critical data. And what I mean by this is, say that I come in and I have to cancel an order. So the second order, 1002, comes in and I void it out. I lose that information. If I void this out, I lose not only the sales data here on the left, but I also lose the customer data tied to that on the right. And again, I want to retain that information. So all three of these anomalies create problems with inconsistent data. If, however, I'm able to come in here and I'm able to separate out my customer data from my sales data and create a separate customer table, I can collect all of that data and have it be the most accurate data. So now I could have a customer, let's say I have customer Teeter, who is living on Broad, and it's linked to both of these records using a foreign key. If Teeter updates his address, then I change it from Broad to Central, and I always have the most recent data for that customer. So now I only have one record for a customer that I can tie to multiple sales orders. I can collect that customer data independently of sales orders, and so I have a lot more control over the specific data that I have. So that's essentially what we're doing with normalization. We're separating out these tables so that we can calculate the data. With denormalization, I may want to come back and make those connections. So I have Teeter on Central for all of these orders so that I can do some analysis. But that will be later on when we talk about data analysis. In the next video, we're going to look at enterprise systems and see how they connect.